Hi, and welcome to the 33rd edition of ChessTDD. Where we left off, I was going to talk about this refactoring the ugly board building method, but what I realized is that I never actually fixed the logic in that should have the following moves method for the scenario of building chessboards and then checking for moves. So if you look right there, what I have is I'm just kind of counting the rows in here in the scenario view, and then counting the number of moves that come back from the chessboard and making sure they're equal. So what I'm going to do here, I think at first I was going to create a whole nother scenario, and then I realized that wasn't necessary because of a technique that I actually use a fair bit, and I might have commented on this before. I'm going to do something different here, and it's not that. I change, well, you'll see. In essence, what I'm going to do is I have this green test, and I'm going to introduce a scenario that should make it fail, but doesn't. So this is kind of an inverted TDD setup compared to what you would normally think about. But, oh, so here's an interesting thing. I made this test red, and then I wanted to start changing the name, but that's generally speaking poor form. You don't want to go red and then also change something that's a refactoring. So I set it back to green and then started refactoring the method. You don't want to do those two things at once. So the refactoring there is just to say that it should have exactly the following moves, which seems sort of unimportant, but I think it's actually, when you get kind of below the surface here, quite important, because we're talking about whether, if I say that the following moves should be present, I think of that as it's technically correct if these moves are present and then a whole bunch of other ones are present. But here I want to indicate with the name of the scenario that it should be exactly this set of moves that you get back, not some kind of subset arrangement. So with the tests back to green, now I'm doing this kind of reversal of the TDD approach, where I have a green test that once I do the right thing, that should go red. I don't know that that's necessarily a part of standard test-driven development arsenal or whatever you want to call it, but it is definitely something that I do from time to time, because I think the thing that you're really looking for is, it's like TDD is like a mini scientific method approach. So you're going to form a hypothesis and then run an experiment. That's kind of what you're doing there. So my hypothesis is that I have this test that's a false green, and what I want to do is make it go red and then put it back. I could do that by duplicating that test and, then having, asserting, I guess, positively over the inverse. Like I could duplicate that test and then assert that, that set of rows should fail or something. In this case, I don't really want to keep that around. I don't think the result of that would be a meaningful test. So I guess what I'm saying is a lesson to learn here is that it is possible, if you conceive of sort of a like a test that should be red, what you can do is throw a knot on it and make the test green. So you could play different kind of, well, I don't want to call it games, but different techniques like that. But in this particular case, I found some value. Like, let me make this test a little different and then get it to go red and then put it back to the way it was and verify that it's green. Again, that might not be part of the standard TDD approach, but for me, I think it's perfectly valid because I am making a hypothesis and then verifying it. And then when I put it back, I'm making another hypothesis and then verifying it. So that's, to me, the crux of the approach. What I'm doing here is now back to the code. I'm using something that I haven't probably shown in this particular series of videos before. I'm using this collection assert, which I don't use a whole lot, but it's a handy way for, I don't want to like do some kind of for each and then iterate through these two collections and make sure that that they are. This should be one assertion. So this equivalent method in collection assert is something I use from time to time to say, hey, I've got these two collections. Let's verify as one conceptual operation that they are the same or they are equivalent. I don't remember exactly in detail what each of these methods on collection assert does. Like there's, I think, are equal or something. That's probably seeing that they actually have the same like object references in there, which isn't going to be the case here. Equivalent is the one I tend to use. Okay, so now I had that test red. I put it back to the way it originally was, and it's green again. So I've actually basically written two tests in the process. I, in effect, then deleted one, is, I guess, the net effect of what I wound up doing there. Now that I have this method behaving the way I want it to, what I'd like to do is kind of get out of this iterator and use link instead. So I'm rewriting this as a selection function of the rows on the table. So it's going to be, let's see, board coordinate 4. I'm just going to have this collection or list of coordinates generated by a link one-liner instead of by the iterator. I personally like the declarative semantics here a lot better. The only trouble is it can get a little bit hard to read. It's something I kind of struggled with throughout the entire course of coding this episode. And you'll see me do it again somewhere else later where it really does seem to be a struggle for a trade-off between brevity and terseness. And on the other hand, readability. I'm trying to get to the best of all worlds, but it's not always easy. So I did run into a bit of quagmire here briefly with figuring out, because like I said, I don't use collection assert a lot, so it was hard for me to figure out what exactly this thing wants. I think it just needs two different implementers of iCollection or something. So I extracted out a method here because I wanted something where I could essentially just give it this table and it would give me back a bunch of coordinates. That's because we're probably going to have reason to do this. Like I was thinking of perhaps later the need to write an assertion just that like a particular coordinate is in the set of moves that are allowed. And while I'm not looking to write speculative code that I don't yet need, I'm thinking of what would be a nice extraction from this method, because that's a good way to kind of think ahead without writing unnecessary code. I'm just making this method more readable and kind of bearing in mind what I might need later if I were going to use this in a different situation. So I'm extracting this method, and at first I said get coordinates list from table, and I kind of slapped my own hand there mentally after doing that because I personally am not a fan of baking type names into method names, because if later I refactor this and I want to, well, so if you look at it right now, it's actually a lie. I'm returning an enumerable and I'm talking about returning a list. But even if it weren't a lie, it might become a lie later. And if you change the return type of that method, you might not think to change the type that's built into the name of the method. So long story short, I am not big on baking the names of types into methods or classes or anything like that, variables. So what you're watching me do here is flail a little bit with figuring out what to return. I get the sense it didn't like the interface types of these things, so I eventually settled on just returning a list, and that seemed to make it happy. It's the kind of thing I probably ought to like research and look into a little, but it's not really relevant to this series of videos or anything I'm really doing. It doesn't solve any particular problem I have at the moment. It would be good for my own edification, but I don't think anyone here is watching these videos to see me staring at the screen and reading about the finer points of collection types in C#. So yeah, you get to watch me struggle a little bit here anyway. But no worries, I think I managed to get it straightened out relatively soon. I think this winds up working. And then it's just a question of getting the right types for comparison. I did also then come in here, as you'll see, and make this a little bit more readable. I'd really like to say to remove as many distractions as I can from asserting what is equivalent. So I'm not necessarily a huge fan of having those two list calls in there. You can see I'm changing the name of that variable into the method to tell anyone calling it exactly what. Yeah, I think I gave up at this point. I'm telling anyone calling that method exactly what to pass in, so don't just call it table. Table of board coordinates, so that if somebody gets confused and they're passing in the ASCII representation of the chessboard, they can see at a glance, hey, that's not the right thing to do. It's especially useful at the moment because I'm not really planning to do a lot of precondition checking here in an auxiliary method for testing. Maybe later, if I were pulling out some more generalized library for all this for other people to use, I'd start doing things like that. But here, it's kind of just a reminder for me. And if I get it wrong, it's a good way to say, "Hey, dummy, you're calling the wrong method, or you're passing in the wrong kind of information." So there, I've done a renaming that I'm happy with, and I want to say that the table coordinates are equivalent to the moves. Basically, the things specified in the scenario are equivalent to the things that we get back from the board. So now I'm on to the original thing that I was looking at here, which is to take this method and do something to make it less ugly and sprawling. You'll see me do a couple of false starts here. I was probably approaching this slightly in the wrong way, where I kind of wanted to come in one fell swoop and write some awesome link one-liner that just replaced all of these. My eyes were kind of bigger than my stomach, so to speak. So I was like, oh, okay, so I'm just gonna have these collections of all the row indices and column indices, and I'm gonna do this refactoring, and it's gonna be great. And then I couldn't really find a good way to make that happen, so I kind of backed it out, and then I tried another false start. What you'll see me eventually get to here, and what I should have done from the beginning, is to maybe start in the middle there, extracting some functionality. One of the main things that TDD provides for me is that it forces me to focus on solving small problems and being methodical. The only time that can become untrue, and you're still following the TDD approach, is in the refactoring part of red-green refactor. So if I were going to write a test, it would be a simple test to expose what I think I need to do next. And if I had a red test, I'd be looking to get it green as quickly as possible. But here it's a refactoring, so that can be as big or small as you want. I have definitely given advice here that you should get to green as often as possible during refactoring, but that doesn't necessarily refer to the planning, where here I'm kind of like scoping out these big bang, all at once, replace it with link. So I won't be red for too long, but nevertheless, this is kind of a failure as I see it, where I wind up just biting off more than I can chew, and then kind of coming back down to earth and figuring out a better approach. So it is, I recorded this, the coding portion of it, just a little while ago, so I still remember freshly like what wound up happening. I don't remember exactly how I got to the end state, but I do remember the end state, so kind of see how it goes. Basically what I settled on was, because I was having trouble immediately conceptualizing how to do sort of this nested select. Like, I want to select all the row indices and then select all the column indices, and I couldn't figure that out. So what I decided that I would do is just do the column ones at first. That's a good interim step. And even though I feel sort of silly now for not knowing how to get right to the solution I got to, just another thing like in last video that shows my rust, I do like the technique of kind of getting in here into this inner loop, or at least around this inner loop, and not trying to solve the whole problem all at once. So I started out and said, okay, what if I just replaced all this inner sort of ickiness with a link statement? And then once I had that working and in place, I could figure out how to also do it with the outer iterator. But I ran into some snags here, one of which was, so I don't know if you're familiar, if you have, you can't do it with enumerable, but for lists and I believe collections, you can do this for each, where you go through the collection or the list and you take an action. It's an action type delegate, or so it's the action type with no so there's no return. I'm sorry. Boy, I'm kind of losing it here with having this stuff right off the top of my head. But so basically, it's the equivalent of a void method, and I'm passing in this one argument, which is the column index. But so there's no return type. A lot of the link stuff, selection, filtration of rows, you can get a single element from it or a collection. This for each doesn't return anything back. You just do something for each element in the collection. Once I figure out the syntax mistake that I have here, this is basically what I want to do, but it's suffering from the problem of lacking this check for null or empty. And that's where you're getting the exception in there, where I think the board builder class is going to toss an exception if you pass in null or the empty string or whatever it is I'm passing in. So I need that if condition. Now, I could put it in there. I could essentially, after, in this lambda expression on the right-hand side, I could replace the builder dot add piece with the check first, and then the conditional adding of the piece if I put in curly brackets, which would essentially make it an inline method. That's already a pretty ugly line of code right there, just in terms of all the different numbers and things that are in it. I don't want to make it uglier, so I think it's about time to turn that into a method call. Now, just like it's my preference when it comes to writing clean readable code, it's my preference if I have something in the body of a control flow statement, like a for or a while, in case you don't know what that means, or even if, to extract a method and just have one line after any given if or while or for. But another place that's good to do that, in my opinion, is when you have the right-hand side of a lambda expression that's getting a little bit hairy. So if I have up there column indices for each CI maps to, and then there's this sort of complicated call, I'd rather that be CI maps to, and then, do something with CI. But it's not going to be quite that simple because there's a lot of stuff going on there in local scope for the method. So for instance, I'm building a board coordinate, but I need the table, I need the builder in order to add piece. So this thing is going to need a lot of stuff in order to do its job, which means a lot of parameters. And usually when I write a method like this, I'd really like to have it be where it's going to be CI maps to, and then some function that just operates on CI as its only variable. That's kind of the cleanest, easiest thing to read and to reason about, but you're going to have to make do with what we have here. So this is still cleaner in my mind. So instead of having all that stuff that's now in the method, I can at least say that CI maps to a single call, even if it does have more arguments than I want. So this is getting a lot more readable to my way of looking at it. I'm going to say, okay, in each row, let me get all the column indices, and then for each of those column indices, I'm going to add a non-empty piece, and I'm going to do it with the builder and the table and, the row and column. Could be better, but it also could be worse, as it was before I got in here and started doing this. So now that that's all kind of squared away, I'm going to look next for, I think I was looking at builder to see if I could make that a class level field and maybe get rid of one of the parameters to that method that's just basically noise. So depending on how builder was implemented, I was probably looking to see if I'd put some kind of like clear method in here or something. I could make the board builder a class level field and just kind of, reinstantiate it in this method every time and then refer to it in that add non-empty piece method. But then I've got this indirection and this sort of hidden dependency. And the problem with this method isn't that it has too many arguments in it. And I'll say this, it's especially true of constructors for classes when you have dependency injection. The problem is that there's a lot of stuff going on here. So hiding it in shared scope where it's not being explicitly passed in is like spraying cologne on yourself when you need a shower. It's not like taking care of the underlying problem. It's just, aesthetically better. So I left that for now, and I figured we could come back to it later. What I'm doing here is getting rid of this other control flow statement. I really like to get away from any sorts of control flow statements in test setup and just generally testing scenarios. It's, to me, just preferable if everything's as declarative as possible. I know I'm cheating because I've got this, for each, but I just very much prefer the declarative style instead of looping and conditionals and all sorts of stuff. So what I'm doing now is flattening this out into a one-liner for both rows and columns. And then that was a nice placeholder until I can do the next thing here, which is I'm making the same exact thing and calling it row indices and then column indices. So how about I just call it indices and I iterate through it twice here. So this is going to become indices, and I'm going to get the same green tests. And now I've got this one-liner. So this is a lot more compact. I've factored out all the noisiness about mapping zero indexed tables that I'm getting in, and then mapping it into the world of chess 1 through 8. So that's all abstracted out of here. Now what I want to do is put this stuff into another call that just kind of builds the board. So I'm going to take this out because this is when I do an extract method, it's going to be the return type. I'm going to ball all this stuff up and have it be the thing that takes a table and returns a built board. Now I think, yeah, I made a mistake. I didn't realize what I was doing, and it created a momentary problem where I named it the same thing as the calling method and then couldn't figure out why on earth isn't this compiling. I started looking at the return type and scratching my head. It took me a minute to figure out the problem. But nevertheless, I'll get this fixed here shortly, and you can see what I'm trying to do here, which is in build board from table, which is the method that SpecFlow invokes. All I really want to say is like, hey, I'm going to give this table to someone, and what I want to get back is a chessboard. And then I'm going to take that and set it in the context. And that's really what's going on here. So I'm going to have these three, I'm going to get 3 deep in the call stack when I do this. First up is just what SpecFlow uses. Then the second thing is going to be the actual like particular mechanics of taking a table and building it into a board, which means invoking the ASCII board or instantiating an ASCII board builder, figuring out what to pass that builder, and then querying it for results. And then there's also that non-empty piece method. I like the non-empty in there because it tells you what the method is doing, and I like the add for the same reason. If I'm going to get real purist about the single responsibility principle, I probably want to even maybe have another method that, I don't know, builds the board coordinate based on the row and column index. Because then right now that add non-empty piece kind of has 2 responsibilities. It says like, okay, I'm going to map the chess coordinates to the zero-based array coordinates, and then I'm also going to do the whole thing where I add a piece to the builder. But that'll be a thing to look at. I'm not even gonna say next time, because you'll see when I go back over to the Trello board here. This is all right now. I think that we can start making progress and not get too fixated on making this test scenario stuff absolutely perfect. So you're gonna see me make this a relatively low priority. I want to start building out more scenarios so we can get back to implementing en passant and castling and some of these other things that are not yet implemented. Those are actual shippable features. Making the spec flow test setup perfect is not something I'm going to ship, nor is it something any of my customers are going to care about. It's important only in as much as it enables me to get things done. Unless I go like make this into a library for other people or something. So that is it for this time. You can see me check this in and almost get it wrong to, commit this to GitHub and then push it up to master. And that's it. I will see you next time around.